not enough room again to complete these problems in a given space, so I'm going to grab another piece of paper here. And I'm going to start by deriving the derivative. So I'm going to substitute in x plus h where I see x. Alright, so I need to continue to find a way to rewrite this. And so I'm going to multiply by the conjugate of the numerator. So it's going to look the same. We're going to have the square root of x plus h minus 3 and the square root of x minus 3 on both the top and the bottom. But instead of subtraction, it'll be addition. As long as you multiply any quantity by 1, and this technically is 1. When you have the same numerator, same thing in the numerator as in the denominator, this is equivalent to 1. So multiplying anything by 1 doesn't change its original value. Well, what can this do for us? Let's look and see. So when I look at these two, when I take these two times each other, I want to remind ourselves, if you took x, square root of x times the square root of x, you just get x. Well, it's the same thing here. When you have the exact same quantity, the square root of the same thing times the square root of the same thing, we can just get to bring it down. So we have x plus h minus 3. That's multiplying fronts. Now the insides and the outsides, if you haven't cut on, the insides and the outsides are the exact same quantity. They're additive inverse. The same thing, one's positive, one's negative. They cancel out. And now I'm going to multiply the backs. A negative times a positive is a negative. And the square root of x minus 3 times the square root of x minus 3 is simply x minus 3. This is in the numerator. In the denominator, it's going to be h times the quantity x plus h minus 3 plus x minus 3. Okay, let's see what we can do on top. So on top, a positive, well, we're going to distribute here. So this becomes, if I'm being lazy, this becomes negative x and positive 3 when you distribute. So a positive x and a negative x are going to cancel out. They're additive and inverses. And a negative 3 and a positive 3 will cancel out. And we're left with just h. So on top, after I simplify all of this, I'm left with just h. H on top and h on the bottom are going to simplify to 1. And I have 1 over the quantity, the square root of x plus h minus 3 plus x plus 3. Okay, so now when I plug in 0 for h, I'm left with x minus 3. Oops, and this was supposed to be a minus sign. Sorry about that. This was supposed to be a minus sign. The square root of x minus 3 and the square root of x minus 3 when I substitute in 0. So I have two quantities of the square root of x minus 3. That means I am left with, when I evaluate this, 1 over 2 quantities of the square root of x minus 3. This is my derivative. So I'm going to come back up here. All right, let's move forward and see what does this problem want us to do. Part A says determine the slope of f of x when x equals 7. So I can simply plug in 7. Oh, you can't see that, sorry. I can simply plug in 7. So when I substitute in 7 here, f prime of 7 equals 1 over 2. 7 minus 3 is 4. The square root of 4 is 2. And 2 times 2 is 4. 1 over 4. Determine the point. Determine the point. So I want an ordered pair. Determine the point when the slope is 2. Okay, so I'm going to replace m with 2. Let's see if I have room here. 2 equals 1 over 2 radical x minus 3. And then I'm going to cross multiply. So I have 1 times 1 is 1. And then I have 2 times 2 is 4 times the quantity x minus 3. I'm going to divide both sides by 4. Okay, to remove the square root, I'm going to square both sides, so 1 over 16 equals x minus 3. I'm going to add 3 to the other side, and there's the x point, the x coordinate for the point. Remember, point contains both an x and a y. So now I need to figure out what is the y. How do I do that? I come right back up here. So I'm going to substitute in 3 and 1/16. Let's see if I have room down here. So I'm going to substitute in 3 and 1/16, and I want to know what is the output. Well, 3 and 1/16 minus 3 gives you just 1/16. And the square root of 1/16 is the same as the square root of 1 over the square root of 16, which provides us an answer of 1 over 4. There is the point, the ordered pair. Write an equation of a line tangent with a slope of 2. Let me grab a piece of paper so I have more room to write this down. I'm told that the slope is 2, and I want to write an equation. I'm going to use y equals mx plus b. You also may use point slope. Mr. McFarland may use that. I prefer that, but there's equivalent ways to write it. So this is y equals mx plus b. I replace m with 2, and I know a corresponding ordered pair here of 3 and 1/16. Okay, I'm going to put that into an improper fraction. 3 times 16 is 48 plus 1. This is 49 over 16, and the y value is 1/4. So I have 1/4. Now if I reduce this, this is a 1 and it becomes an 8. 49 over 8. I'm going to move it to the opposite side by subtracting. I'm going to take this times 2 and this times 2. So I have 2 over 8 minus 49 over 8 equals b. 2 minus 4, negative 47 over 8. Okay, that's my b value. Once I have my b, my final answer is y equals 2x minus 47 over 8. That's the equation of a line, equation of a tangent with the slope of 2. Let's look at our last one. What is the equation of a line tangent that passes through the point 4? Passes through the point 4. Okay, so I'm going to start by, let me see if I can flip this around here. I know the x value is going to be 4. So I come up to this original right here, my f prime, and I'm going to substitute in 4. Four minus 3 is 1, the square root of 1 is 1, and I'm left then with 1/2. Okay, so I know I have 1/2 for the slope. So y equals 1/2 x plus b. Now, where do I get the ordered pair? It's right here. There's my x and my y. My y is 1. My x is 4. Let me move this down so you can continue to see this. Half of 4 is 2. Move 2 to the other side. 1 minus 2 is negative 1. My final equation of a line tangent that passes through this will be y equals 1/2 x minus 1.